Bismillah ar-Rahman ar-Rahim. Um, we are again having, by the government orders, the online classes. So to make it more optimal, we are reading the optimization techniques. We have to apply the optimization techniques in our lectures also. So the mechanism is to have a video class. Then the assessment mechanism is also there with the Google Forms. In a 1 week time, we will have the assessment questions coming up in the form of Google Forms, which will be a quiz. Okay, and then we also will have a doubt clearance session at the end of a week that will help us to strengthen our concept. Okay, so today we talk about 2 into n games and how to solve that if we have a 2 into n games, and uh, how which methodology you apply for this and how you do that. So all these steps we are going to cover today. Okay, so what is a 2 into n game is that 2 is for the player A and n is for the player B. That means the player A has two choices to make. He can either go for the 1 or 2, but the player B has 5 strategies. So player A can go for the only 2 strategies and player B has many strategies. So definitely here the player B has an advantage, okay, to choose from many of the 5 strategies which is best for them. So player B, we know it will try to minimize its loss. Okay, it's about minimax, and player A is about maximin. It is trying to maximize the minimum gain, whatever it has. So one of the methods to solve the 2 into n games, why I said 2 into n, you could understand it because 2 is for the player A and n, it could be 5, 6, 7, means many than what the player A have. Before we had a 2 cross true, okay, where we used the odd means. So we had only 2 cross 2. So where we have the 2 options here and the 2 options for the player B as well. Okay, so in that scenario we can use the odd means and calculate our values and solve it. If it is not having a saddle point and all, we know that. If it is a mixed strategy, not a pure strategy, we have understood that thing also. So but if it is at all, if it is a pure strategy where we have a saddle point, then that is a solution. We don't want to go forward, but these things we solve graphical method. For example, we solve 2 into n games using graphical method if it is the mixed strategy, not a pure strategy, because in pure strategy there is a saddle point and that's the solution, that's the value of the game, right? So what should be the first step? So in any game problems, what we have is we first check the saddle point, right? So that's also valid for this graphical method solution also. So the first, what we do is we first check the saddle point of the game, and this game has no saddle point. Let us see if this game has saddle point or not. So let us see it. So how we calculate the saddle point? We go here and see which is the minimum in this row, because we see the row minimum. We have already done it, we know it. So -6 is gonna be the lowest here in this row, and in this row who is gonna be the lowest? It's -9, right? Nice. And for columns, that's for the player B, because in the player A want to see the minimum, what is the minimum gain I am having, and in these minimum gain the player A will try to maximize the minimum gain, so to try to find the maximin. Okay, and I'm seeing -6 is the bigger than the 2, so this is my max min. But for player B, it will try to see, because it's loss, because it's going to, if it is a positive numbers, it is going to actually to the player A. So what will be player B trying to do? It will try to see what is the maximum loss I am having. So I will try to, what is the maximum among the column, that is 3. In this column it is 2, and here it is 7, and so on. So out of these maximums, because he's seeing this is the maximum I'm having, so what is the maximum for player B? Is the loss. Okay, So because this is the payoff matrix of actually player A, so it's all its loss. So it will try to see which is the minimum, because we see the column max, and which is the minimum among them. So that's gonna be the 2. Okay, this is gonna be my minimum out of max. That's minimax. So is my minimax equal to maximin? No. So min max is not equal to maximin. So what is this? Is this a pure strategy or mixed strategy? Yep, you're right, it is a mixed strategy. So we have to solve it anyways. Okay, we cannot we don't have a saddle point. That means we need to solve it, either the dominance property we have seen, or some other mechanism, or here for the 2 into n games we have a graphical method to solve it. So we will solve it by the graphical method, right? Before we step our foot on the graphical method, we can reduce the size of this payoff matrix by applying the dominance property, or it's not required also. If you don't want to go for the dominance property and reduce the size of the matrix, this payoff matrix, it's okay, we can directly go for the graphical method. Or to simplify it, we can use the dominance property to reduce it, to shrink it, to remove a few rows or columns, right? So what we do in the dominance property, we just first see the row dominance, then the column dominance, right? So in a row dominance, which belongs to player A, we try to see which one is the least profit I'm having, and I want to remove that. So for that, I will calculate the row total first. So calculate the row total. Okay, so what's the row total? This minus 6 and 6 is gone. This 5 and minus 4, there's 1. 1 plus 2 is 3. So total is 3. And for this guy, minus 9 and 8 is gone, and 1 from again this minus 9. Then this is 6 plus 4 is 10, plus 3 13. So which is the lowest total? That is 3. So I will try to see this row. If this row has each and every element lesser than the corresponding row element, okay, if it's so, then I will remove that. Is minus 4 less than 3? Yes. Is 2 less than negative 9? No. So there is no row dominance. So I'm not having any row dominance. So let us go for the column dominance. Okay. So in the column, I will see the total first. So negative 4 and 3, that is 9 minus 1. This is gonna be the minus 7. This is gonna be the 12. And this is gonna be 6 minus 6 4, that is negative 2. And this is 8 plus 6 14. So this is the column dominance is seen by the player B, and player B want to, because for this is the loss, right? So it will try to see which is the bigger column, and I want to remove that. So for that, I will first see which is the biggest element, that is 14, and try to see if 6 and 8 is greater than the other corresponding column elements, then I will remove it. Is 6 greater than negative 6? Yes. Is 8 greater than 4? Yes. So I'm going to remove this. Okay. Now, what is the next bigger element? That is 12. So I will choose the 12. And now I will see the element 5 and 7 in this column. Are they greater than the other columns or not? Is 5 greater than 2? Yes. Is 7 greater than negative 9? Yes. So remove this. And what is the next bigger element? That is negative 1. Is this greater than the other guys? Is negative 4 greater than 2? No. So I can't remove it. Let us check it with the 6. Is minus 4 greater than negative 6? Yes. Is 3 greater than 4? No. So there is no column dominance. So I will stop it here. So I have reduced my matrix to minus 4, 2, minus 6, and 3, negative, and 4. So these elements are gone. So what I have done with the dominance property is I have reduced the payoff matrix. Even though if you don't want to do that, you want to just go directly to the graphical method, you can go it. But if you want to reduce it, you can reduce it. So this is my reduced payoff matrix. So I removed the 2 columns, okay, and I got the 2 rows and 3 columns, okay. Now let X be the probability of selection of alternative 1 by player A, and 1 minus X be the probability of selection of alternative 2 by player A. What does that mean is, we know the sum total of probabilities is always going to be the 1. right? Because if I have the probability of 1 second, if I have the probability, say for example, some probability, I'm saying probability of choosing this one, okay, and I have a two choices of the A. What is the probability that player A will choose one, and what is the probability of player A to choose two? Say for example, to choose one, the probability is X, and to choose two, what will be the probability? Because sum of the probabilities of both will be equal to 1. So that means this one, whatever the probability of choosing the 2, because this is the probability of choosing 1, that is this one. And what is the probability of choosing 2? That is this one here, the 2 one. Okay, that will be, if I go get the x on the other side, so that's going to be 1 minus x. So if I have a probability of choosing this 1 as x, then probability of choosing 2 is going to be 1 minus x, right? We have to understand this first. So after finding the probability, what are we going to do? We will see what is the probability of B, choosing some option, and what is the probability that A will use that. So what will be the function? Okay, we'll try to find the function of A, what you call as the expected gain function of player A with respect to the player B's all the options it has. So how we calculate that? Because I know in the first, if I see first row, first column, -4 and 3, this is what the player B can choose if he chooses among the first column. So what will be the probability of player A, or the gain function of player A will be whatever the B chooses. Say for example, -4 times x is the probability of player A, plus 3 times 1 minus x, which is the probability of player A. So add them together. This will be the gain function for this column for player A. Same is with the, if the player B chooses the column 2, either 2 or -9, so that means what will be the gain function of player A? That will be the 2 into x plus -9 into 1 minus x. And same is with the, if the player B chooses the column fourth, now here, which is column third, okay, in the beginning table it was fourth, so we reduced the 3 by the dominance property, okay, and the fifth column by the dominance property. So this is my the third column now, which was the fourth in the first table, initial table. Now what will be the gain function of player A? That is -6 times x plus 4 times 1 minus x. So what we do is we derive the expected gain function of player A with respect to each of the alternatives of player B. So how we do that? We multiply the column values of B's alternative with its corresponding probability selection of alternative by player A. यानी कि जो भी column values हैं उसको जो probability A की है उसके साथ multiply करेंगे और plus करेंगे जो next value होगा, ठीक है ना? जैसे कि first alternative player B is column number 1, so we multiply -4 with x and 3 with 1 minus x and add them together. So -4 with x and 3 with 1 minus x and add them together. Same is with the next column, 2 with x, multiply 2 with x and -9 with 1 minus x and add them together. That will be the gain function of player A to the corresponding second जो column है player B की choice. Okay, so here we go. This is second alternative of player B is the column number 2, so multiply 2 with x and -9 with 1 minus x and add them. Similarly, the third alternative of player B, what will be that? If we see the table, you have to multiply -6 with the x and 4 with the 1 minus x and add them together. So you do -6 with the x and 4 with -1 minus x and add them. Okay, right. Now after this thing, we move on to the step third. So in step third, what we do is we calculate the A's expected gain if B chooses either column 1 or 2 or 4. Okay, for the B, for the B, it can choose either column 1 or 2 and 4, and I have the player A's expected gain function. With that, I will calculate its expected gain. Okay, because I want to see whatever the B plays, I want to maximize the gain. The A will try to maximize its minimum gain, right? Maximin. So overall, what are we trying to do? If we zoom out from this? What are we trying to do? Because we had a matrix here. If I go back to my first matrix, if I'm having a 2 into n matrix where I had a 5 columns. So overall, if I say what I want to do is I want to break this into 2 by 2 matrix so that I can use odd bins and solve it. This is the question which was asked by a girl in the class also. Okay, so I don't remember the name. So this is the I told her to wait for the answer. So this is the answer. So if you have the 2 by 3, 2 by 5, 2 by 9 or whatever games, and we can also have m into 2 games also, where the player B has 2 options and we have player A has m options. Okay, that's not in your syllabus, but that we can have the inverse of it also. So in that case also, we want to break this matrix into 2 by 2, and where we can use odd bins to find the solution. This is what we want to do by the graphical method also. We want to break this into 2 by 2. So this is what we are going to achieve by this graphical method. We get a 2 by 2 matrix. Okay, so here B has an alternative, either choose column 1, 2 or 4, and we are seeing what is the expected gain function, payoff function of the A, because we said that we have to multiply this -4 with the x plus 3 with the 1 minus x. So this is what we get here, -4 into x plus 3 into 1 minus x, that is -7x plus 3. And same is the second column and same is the third column, plus them together and we get these values, right? Then we see what is the A's expected gain. So how we see that? We say whether x is 0, the probability of choosing that is 0 or 1. That means either you are choosing it or not choosing it. If you are not choosing it, what is your expected gain? And if you are choosing it, what is your expected gain? So if you are not choosing it, x will be 0. So that means you are not choosing it. So B is choosing it. So what will be the your expected gain? But if you choose this one, okay, that means x is 1. So what is going to be your expected gain? So this is how we do it. We substitute this x 0 here in the 7x plus 3. If the x is 0, this is gone, so answer will be 3. But if it is 1, so -7 into 1 is -7, -7 plus 3 is -4. So that means you will see here it is -4 coming up and it is 3 coming up. So obviously we will be choosing 3 if we see the A's expected gain. Same is here, you substitute x0 or x1. If you substitute x0, this is gone, this will be -9. If it is 1, that is 11 minus 9, that is 2. For this guy, again, we get the 4 and -6 value. Now, after getting the A's expected gain, what we do is we got to go to the step 4, where we plot these on the graph. So if B selects the first strategy, A's expected gain is 3 for x is 0 and -4 for x is 1. So if B chooses 2, the second strategy, then expected gains are -9 and 2 for x is 0 and x and 1. And if B chooses the third alternative, that's 4, then my expected gains are going to be 4 and 1. So this is what is written here. Okay, it depends on what B selects. If he selects first strategy or second strategy or the fourth strategy. In fact, now that's the third strategy, right? Or from the original table, it is the fourth strategy. So if it chooses, what will be the expected gains of A? Okay, so using this information, we plot these points on a graph. So I will plot for x is 0 and x is 1. So I need to have a two vertical axis for x is 0 and x is 1. That is here. This is for x is 0 and for x is 1. Okay, one second, draw. So this vertical axis is for x is equal to 0 and this vertical axis is for x is equal to 1. So I have got the for this is the first strategy. If the B selects the first alternate, that's the first strategy. What will be the A's expected payoff? A's expected payoff is 3 and -4. So for x is equal to 0, it will be 3. For x is equal to 1, it's -4. So I'll make a line from 3, that is here, okay, to -4, that is here. So I make a line. This is my line 3 to -4. Okay. Now, if B chooses the second strategy, So what will be the my points for that? If we choose second, so that's negative 9 and 2. So negative 9 will be on the x0 axis, that is here. Okay, as you could see, negative 9. And then 2 will be on the x is equal to 1 axis, that is this is my x is equal to 1 axis. Okay, that's a 2. So I make a line of it. And then if the B choose selects the third alternative, that is the fourth strategy, then what are my points there? They are 4 and negative 6. So 4 on this side, okay, and negative 6 on this side. So I make a line. I made this all these lines, and if there are other lines also, we have to draw them together. And then we go to the step 5. Now, what is step 5 is we find the highest intersection point in the lower boundary of the graph. If it is, this is 2 into n matrix. If it was its inverse, that is m into 2 matrix, that is if we have the graph where we have, one second, draw. If we have the 2 columns and many rows, that is m into 2, then we see the higher part. But in 2 cross m matrix, where we have 2 and many columns, okay, 2 cross m, we see the below portion of it. In the below portion of it, we will see the intersecting point, the highest intersecting point. Sometimes, the lower part is this one. This is my lower part, right? And what is the intersecting point? That is this point B. So in this A, B, C, this B is the highest point, because I want to see the highest maximum point, because from the A's perspective, we want to go for maximum, that is maximize the minimum gain. So we always try to see the maximum point in this scenario. So what we have to do after plotting the graph, just go for the lower area and try to see the maximum intersecting point. Okay, and that is your maximum point. This point is called the maximum point, and I see that only 2 lines are joining it. Okay, only 2 lines are on this point. So which 2 lines are these will be selected as my 2 by 2 matrix. So if you could see, among the 3 lines, there could be many lines, there could be many other lines also. Right now I have only 3 lines. There could be other same lines also. So they are going maybe from here to here. I will all cancel all of those lines. I will only choose the intersecting point lines. That is this B2, and this is gonna be my B4. Okay, so B4 is when you have the fourth strategy, and B2 is when you have a second strategy. So the first strategy, I don't take it, so I take only these 2 guys. So this helps me to get the 2 by 2 matrix. Now after finding the 2 by 2 matrix, we will go for the arguments. Okay, so for the arguments, we just subtract the 2 and use the first the positive values. So use the 2 minus 6, that is 2 plus 6, that is 8. So write it against this one. Okay, write the 8 here. And same as this, use first the positive value. 4 minus 9, that is 4 plus 9. Minus is plus. 4 plus 9 is 13. So write it here. Same is with the columns. Okay, 2 minus 9. So 2 plus 9, that is 11. Write it here. And 4 minus 6, that's 4 plus 6, that is 10. Write it here. Okay, now what will be the probability? Probability of this one will be 13. So probability, okay, that is 13 divided by 13 plus 8, that is going to be 13 divided by 21. And for this one, this is 8 divided by 13 plus 8. Okay, sum of the two, that is 8 divided by 21. Okay, as you could see here, 13 divided by 21, 8 divided by 21 as the probability of player A. What is the probability of player B? That's for this we had to go to the column. So for 10, this will be 10 divided by 10 plus 11, that is 21. So 10 divided by 21 is going to be the probability of player B for the second row. Okay, for the second, that's why for the second it is 10 divided by 21, because initially we had the 5 columns. Okay, there are 2 rows and 1 2 3 4 5 columns. 1 2 3 4 and 5, and we are only using 2 and 4. For 1, 3 and 5 we have zeros. For 1, 2 is here, 3 is 0, 4 is here, 5 is here. For 2 I got 10 divided by 21, and for the 4, okay, I got 11 divided by 21. Okay, 11 divided by 10 plus 11, that is 21. So 11 divided by 21 is the probability, and 0 for the fifth column because I'm not taking that. Okay, so probability of player B is 0 for the first column, 10 divided by 21 for the second column, 0 for third, 11 divided by 21 for the fourth column, and 0 for the fifth column. So what will be the value of game? Value of game, we know. What is the value of game? So how we calculate value of game? Value of game we calculate, we can use many ways. Okay, firstly, if I use this row, so I have to multiply 2 with the 13 plus minus 9 with the 8. So if I 2 into 13, okay, and plus it with minus 9 into 8, okay, and divided by 13 plus 8, 13 plus 8, 13 plus 8 means 2 multiplied with 13 plus minus 9 with the 8 divided by 13 plus 8, or I can use minus 6 into 13 plus into 8 divided by 13 plus 8, or I can go column wise also. I have shown it all the options that time, and this, if you calculate, this is coming to be minus 46 divided by 21, which is here. So that is the solution of the game. Okay, so that is all for today, and this is how we solve our problem of 2 into n matrix by graphical method. So how we do it? We first broke it. We see first the saddle point. If the saddle point is not there, so it's a mixed strategy, so we have to apply the graphical method. Before we apply the graphical method, we reduce the size of the matrix by dominance property and see the row and column dominance, and remove some columns and rows, columns if at all you can remove. Then this is my reduced matrix. Then see the probability of x, and 1 minus x is the probability of the next taking. If x is the probability of taking choosing the first strategy by player A, then 1 minus x will be the strategy for taking strategy second by player A. Then see the A's expected payoff matrix. Okay, and then if you choose the x, and if you not choose it, see the values, plot these values on a graph. Okay, and see the lowest in the lower part, see the maximum, because this is the minimum, because we see maximum for minimum part you go to the lower part of the graph and try to see the maximum point. Okay, and see which lines are intersecting, two lines are intersecting, that choose only those two and discard any other line. So that means you will get the 2 by 2 matrix, and then use the oddments, which we had done already. Okay, and solve your problem using the oddments then. So that's all for today. Thanks for watching this, and see you in next video inshallah ta'ala. Until then, ma salama.